For writing Bondline formula, we have to know some points. So these are the points to be noted before drawing the Bondline formula. The first point is the terminals represent methyl groups. So while drawing the Bondline formula, we should know the terminals are actually methyl group. Then the second point is line junction denote carbon with appropriate number of hydrogen atoms. So there are line junctions in between. So those line junctions denote carbon with appropriate number of hydrogen atoms. That means number of hydrogen atoms are required to satisfy the valency of carbon atom. So that is represented by the line junction. Then the third point is carbon and hydrogen are not shown. So in Bondline formula, we are not drawing carbon and hydrogen. Then the fourth point is heteroatoms like sulfur, nitrogen, oxygen and halogen, any halogen, fluorine, chlorine, bromine, etc. are shown, and also the hydrogen attached to them are shown. So carbon and hydrogen are not shown in the Bondline formula, but sulfur, nitrogen, oxygen and halogen are shown in this formula, and also hydrogen atom attached to any of these heteroatoms will be shown in this formula. Then the fifth point is bond between carbon atoms are shown. So if it is a double bond, we will show that double bond. If it is a triple bond, that bond also we will draw. So it is drawn in a zigzag fashion. So we will draw the Bondline formula in a zigzag fashion. We can start like this, or we can start like this also. So we can start from here, or we can start from here. So anyway, we have to follow a zigzag fashion. So these are the 6 points to be noted before writing or before drawing the Bondline formula. So let us illustrate these points by drawing some examples. So let us draw the Bondline formula of these compounds. First compound is hexane. So it contains 6 carbon atoms. We can draw like this: 1, 2, 3, 4, 5 and 6. So in a zigzag fashion we have drawn the Bondline formula. So we can draw like this also. We can start from here: 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and 6. Here also 1, 2, 3, 4, 5 and 6. So both are right. So this is the Bondline formula of hexane. Then the second compound is 2-methyl pentene. So pentene means it is understood it is pent 1-ene. So first of all we have to draw the Bondline formula of pentene. So it contains 5 carbon atoms. So 1, 2, 3, 4 and 5. So pentene means pent 1-ene. So this is the first carbon. So we have to draw a double bond here. Then it is 2-methyl. 2-methyl means second position methyl group. So this is the second position, and we have to draw a line here. And we should not write CH3 here. This line represents CH3 itself. So this is the Bondline formula of 2-methyl pentene. Then the next one is 2,2-dimethyl pentane. 2,2-dimethyl pentane. So we can write 1, 2, 3, 4, 5. So it is pentane 1, 2, 3, 4 and 5. It is 2,2-dimethyl. So this is the first position, this is the second position. So we can draw 2 lines like this. So this line represents one methyl group, this line represents another methyl group. So we have to draw like this in order to keep maximum distance between atoms. So this is the Bondline formula of 2,2-dimethyl pentane. Then the next compound is 3,4-dibromohexane. 1, 2, 3, 4, 5 6. So it is hexane. So 3, 4. 3, 4 means this is the first position. 1, 2, 3. So this is the third position. We can draw a bromine here. Since it is a heteroatom, we have to write bromine. And fourth position also bromine atom, and we have to draw bromine here. So it should be like this, not here. It should not be like this. It should be in this way in order to maintain maximum distance. So this is the third position, this is the fourth position. So this is 3,4 dibromohexane. Then the next compound is 3-methyl-hexane 1-ol. So 3-methyl-hexane 1-ol. 1-ol means it's an alcohol. So it contains 6 carbon atoms. So 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and 6. So hexane 1-ol. 1-ol means OH is there, and we have to write an OH, separate OH. So 1, 2, 3, 4, 5, 6. Then OH. Here hydrogen atom is attached to a heteroatom. Hydrogen atom is attached to oxygen. So it should be written. So we are writing OH here. Then 3-methyl-hexane. So this is the first carbon. We know that the carbon which is attached to the functional group is the first carbon. So this is the first carbon. Then 2 and 3. So this is the third carbon. So this is the third carbon. So we have to draw a line here since it is 3-methyl. So it's a methyl group. So we have to draw a line here. So this is methyl group and this is OH. So this is 3-methyl-hexane 1-ol. So we know that CH3, CH2, CH2, so this is hexane, and if it is hexanol, this will be CH2OH, and this is the first position, second, third, fourth and fifth and sixth. Then third position methyl group means this is here, this is the methyl group. So first position OH group, third position methyl group. So 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and 6. 6 carbon atoms are there, and OH is attached to this carbon atom. OH is attached to this carbon atom. OH is attached to this carbon atom. That is the first carbon. Then 2, 3. So this is the first carbon. 1, 2 and 3. So I think it is clear to you. 3-methyl-hexane 1-ol is represented like this. Then the next compound is pentan 2-on. Pentan 2-on. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So 2-on means we know that C double bond O. So we should not write C here. So we are not writing C and H in bondline formula. We have to draw the oxygen atoms and also the double bond. So we have to show the bonds between atoms in bondline formula. So this is pentan 2-on. So we know that CH3, C double bond O, CH2, CH2, CH3. So this is a formula, condensed formula. CH3, CO, CH2, CH2, CH3. 1, 2, 3, 4, 5. So this is the second position. So 1, 2, 3, 4 and 5. So this is pentan 2-on. So first position is here, then second position CO group is there, and that C should not be shown and double bond O should be shown. So this is the bond line formula of pendant 2-on. So let's see the seventh compound, that is 2,5-dimethyl heptane. It is heptane, that means 7 carbon atoms. So 1, 2, 3, 4, 5, 6 and 7. So 1, 2, second position a methyl group, then second, third, fourth and fifth. So it should be like this. So in order to keep maximum distance, we have to draw lines like this. So this is the second position and this is the fifth position, and this is 2,5-dimethyl heptane. Heptane means 7 carbon atoms, 1, 2, 3, 4, 5, 6 and 7. So this is the bond line formula of 2,5-dimethyl heptane. So let's see the next compound, that is propan-2-ol. Propan-2-ol. So 3 carbon atoms, 1, 2, 3. So 1, 2 and 3. So 2-ol means second position there is an OH group. So OH group should be shown. That means O is a heteroatom and hydrogen is attached to that heteroatom. So that should be shown. So this is the bond line formula of propan-2-ol. Now let us write 2,3-dimethyl butanol. 2,3-dimethyl butanol. So butanol means 4 carbon atoms. So 1, 2, 3 and 4. So 1, 2, 3 and 4. So butanol, al means that is an aldehyde group. Aldehyde group is C double bond O H. So this C can be, this C, the position of this C should be here, and it is, there is a double bond O and there is a hydrogen atom and that is connected to carbon. So it is not to be shown. So this is the first position, then second position, then third position. So first position, second position, third position. So second position is this. So this is, there is a substituent, that is methyl. So here there is a methyl group. So this is a second position and this is the third position. So there is methyl group, here also there is a methyl group. So this is the first position, then second position, third position, fourth position. So the functional group, the carbon atom in the functional group, that is, that carbon is the first carbon. So this is the first carbon. This is the aldehyde group is like this, C double bond O H. So double bond O should be shown. Hydrogen is connected to carbon, so that should not be shown. So this is the bond line formula of 2,3-dimethyl butanol. Now let us write octanoic acid. So octanoic acid means it's a carboxylic acid. That means it contains C double bond O OH. So this is actually the functional group. COOH is the functional group. So this can be drawn like this, C double bond O OH. So octanoic acid means it contains 8 carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8. So this carbon is the carbon in the carboxyl group. So this is, we have to draw O here, double bond O and OH here. That means here the hydrogen is connected to a heteroatom, so that should be shown. So C double bond O and OH. So this is the carbon, 1, 2, 3, 4, 5, 6, 7 and 8. So actually this is CH3, CH2, CH2, So 1, 2, 3, 4, 5, 6, 7 and 8. So this is a condensed formula. So from this it is clear that this is the correct bond-line formula. So this is about the bond-line formula of organic compounds.